Typically, I don't go over homework in as much detail as I'm about to, but I selected these 5 problems for very specific reasons. And I think that there are some typical uh, issues students have when they walk into Algebra 2 with solving. And it's not necessarily that they get questions wrong, but they don't take the most efficient path. And something that I hope for you before you leave my class is that you are very, very, very good at solving equations, any equation I throw at you. And on top of that, that you can do so efficiently. Now, if you are in a test or quiz situation and you're taking a test and you have to solve an equation and you choose a method that is a method that I don't consider to be the most efficient, that's fine. As long as you are able to finish a test, that is completely fine. But I want you to be able to have a whole bunch of different tools in your toolbox when it comes to solving. So I want you to be familiar with different methods so that you can become more efficient, that you can become better at solving. So I'm going to go over this homework, and I might not finish every question, but I'm going to get you past the point where I think you would be fine for me to leave you on your own. So I'm going to basically at least get you started with every single question, but then I might stop and let you finish on your own. The first one, question number 1, the first thing I hope that you notice is this is a linear equation. What makes it slightly more challenging is the fact that there's fractions throughout the equation. So something that I would do in a question like this is what I call fraction bust. I think we can all agree that this equation would be much easier to solve if there weren't fractions. So I'm going to get rid of the fractions. So I'm going to look at my denominator, and I'm going to I see my 7, the 2, and the 4, and I think, what number can I multiply by that will eliminate those fractions? So something that's divisible by 7, divisible by 2, and divisible by 4. Well, essentially what that number is the least common denominator. So we are going to fraction bust with the least common denominator. So what's the least common denominator of 7, 2, and 4? Well, 2 goes into 4. So then I only have to worry about the 4 and the 7. Well, 4 and 7 multiply to 28. So in this case, the LCD is 28. So I'm going to take 28 and I'm going to multiply both sides of the equation, which we know we can do, properties of equations, or properties of equality. I can multiply both sides by any number I want, and the equation will still be true. So now when I distribute this 28 to both sides, I'm going to be left with integer coefficients. So 28 times 2/7. I know I have to multiply by 2 and divide by 7. Well, as I do this in my head, I'm going to divide by 7 first. So 28 divided by 7 is 4, times 2 is 8, which gives me 8x. 28 times 1/2. Well, if I divide that by 2, I get 14. And then times by -1 is still 14. 28 divided by 4 is 7. 7 times 3 is 21. And then here, there's not a denominator, so I just have to do 28 times 5. Well, 20 times 5 and 8 times 5 add to 140. And then from there, I would just keep going. And I think you guys can solve that without any help from me from there. The one thing I will tell you, don't round your answers, just leave them as fractions. Once you round it, it's no longer technically the solution. It's a very close solution, but it's not perfect. In number 2, the first thing I hope that you notice is that it is a quadratic. And in most cases, the first thing that we're going to do with a quadratic is set it equal to 0. And I'll show you a case where I wouldn't do that. But the first thing I'm going to do is set it equal to 0. So I'm going to subtract 2x and I'm going to subtract 2. So I have 2x squared plus 3x minus 2 is equal to 0. And once you have a quadratic equation in standard form, so like it's expanded out, you have 2 options we tend to pick. We can factor, and then we can use the quadratic formula. And I'm not sure where this comes from, but students walk out of Algebra 1 and they love the quadratic formula. And it probably comes from the fact that it works every single time. Personally, I don't enjoy the quadratic formula. It is long, it is tedious, and it is a whole lot of work. So if I can avoid it with factoring, I will 100% of the time, unless I can't figure out the factors, which doesn't happen very often. So I always check for factoring first. When we get to some later chapters in this class, we are going to do a ton of factoring. So if you are rusty on factoring, now is the time to practice. You need to look up some videos. You need to go back to your Algebra 1 notebook. You need to find out how to factor basic quadratics and basic greatest common factors. And anything you can do to help yourself right now will make your life a whole lot easier come October. All right, so first, 2x squared plus 3x minus 2. I know that when I factor, I tend to use guess and check. I know whatever I put right here and right here has to multiply 2x squared. Well, 2 is prime, so my option are 2x and x. And then whatever goes here and here has to multiply to negative 2. So what I do is I ignore the signs and I just put the numbers in. And so I'm going to do what I call guess and check. So if I were doing this problem, I would stick a number somewhere. And at this point, I do it in my head, but I'm going to show you guys my thought process. So let's say I were to put a 2 here and a 1 here. Well, automatically, I know this is not going to work. And the reason I know this is not going to work is, do you see how there is not a greatest common factor here? But if I put a 2 here, that makes the greatest common factor of this set of parentheses 2. Well, 2 can't be a factor of something if it wasn't a factor of the original. Meaning the only option I have is to put the 1 here and the 2 here. So then I start my check. This is 1x and this is 4x. Well, can I get to 3x with 1x and 4x? Well, yes, I want a positive 4x minus 1x, and that will give me 3x, positive 3x. The last thing you have to check is make sure that negative 1 times positive 2 gives you a negative 2. Every once in a while, it will just so happen that you will end up with the middle term, but you'll end up with the opposite sign here, and you want to make sure that doesn't happen. And then once you have your factors, whoops, I don't have a parenthesis there, set each factor equal to 0. My pen got really light. And then solve. So you have 2x equals 1/2, and then x plus 2 equals 0, x equals negative 2. So you have those two solutions from your factors. All right, number 3, huge pet peeve of mine. You are not allowed to divide by x when you are solving an equation. You can divide by a number. You may not divide by x. This is a quadratic. You should expect 2 solutions. With quadratics, we tend, when we're expanded, to set it equal to 0. You should do that. Then take out your greatest common factor. They both have an x. So we are undistributing an x from both terms. And then set both factors equal to 0 and then solve. And there are our 2 solutions. All right, number 4 is the type of quadratic equation that I would not set equal to 0. And if you notice, the only place that x is in this entire equation is inside this squared. So I'm going to use inverse operations. I'm going to undo everything that's happening to x in order to solve for x. So the first thing I'm going to do is subtract 5 from both sides. So we have 6 times x minus 7 squared equals 18. And then I'm going to divide by 6. And then I'm going to take the square root of both sides. Remember that you need to make sure that you introduce your plus or minus. Hopefully you remember that from Algebra 1 or geometry. So if you square root both sides of an equation, you need to make sure that you introduce a plus or minus. If you need to remember where that comes from, if I'm trying to think about what would make this true, if I square something, it automatically makes it positive. So there are 2 things that I could square to get 3. I could square radical 3 to get 3, or negative radical 3 to get 3, which is where that plus or minus is coming from. And then finally add that 7 over. So I get x equals 7 plus or minus radical 3. Notice I didn't round. I didn't type it in my calculator. You pretty much shouldn't be using a calculator at this point. There's not much you need a calculator for. So you should just be doing this by hand. And then the last one, notice this is in standard form, and you can't just isolate x by undoing operations or inverse operations. So I'm going to set it equal to 0. And again, I notice a fraction. So you kind of have an option here. You can try and factor with a fraction, or you can get rid of the fraction. So I'm going to multiply both sides by 2, which gives me, whoops, I don't need that there, 3x squared minus 6x minus 14 is equal to 0. And then I would try to factor, and you're going to see pretty quickly. So we know this has to be 3x and x. My options of numbers that multiply to 14, I have 1 and 14, 2 and 7. So I would probably start with 2 and 7. So this would give me 6 and 7. That's not going to work. That's what I just had. So that make that a 2. So that's going to give me 2x and 21x. I'm still not getting to negative 6. And then 14 and 1 is not going to get me there. I think you guys can see that pretty quickly. So this is a case factoring is not going to work. So I would jump to quadratic formula. A quick tip, the way, and we're going to talk at length a little bit later why this works, but when you were doing the quadratic formula, so we have x equals, you should remember this. Actually, you can look it up. I'm not even going to write it down. X equals the opposite of b plus or minus the square root of b squared, which is 36, minus 4 times a times c. I did that twice. I want it to be a 4. All divided by 2a. When you do this, in order for you to get rational answers, so remember rational numbers are numbers that can be written as fractions. In order for you to get rational answers, this square root would have to go away. The radical sign would have to go away, meaning the number inside would have to be a perfect square. So in order for something to have been factorable, so if this original equation was factorable, we know that this number underneath the radical would be a perfect square. So that is a check to see if something factors. If you're discriminant, that's what this number is. So if the discriminant is and I'm going to write positive, as a positive perfect square, then the original equation was factorable. And we can abbreviate equation EQN, just so you know. And this is just a little tip, and this is going to be really helpful later when I am expecting you to factor functions. So there's going to be a point when you can't just solve it using the quadratic formula. You have to factor it. And so this is going to be something that's good to know. Anyways, from here, I think you guys can clean this up on your own. So you end up with 6 plus or minus the square root of 204 all over 6. You need to simplify your radicals. So you need to find the largest perfect square that goes into 204. 204 is the square root of 4 times the square root of 51. The square root of 4 is 2. So then we get 6 plus or minus 2 radical 51 all over 6. And then we can reduce. I'm looking at this 6, this 2, and this 6. They're all divisible by 2. So I have 3 plus or minus radical 51 all over 3. If you feel like I'm going kind of fast, this is not the pace that we would necessarily go throughout the year, but all of this should be review. All of this is coming out of Algebra 1. You might not have seen it grouped together like this. And I know Algebra 1 was a while ago, but this is all old stuff. And that's kind of why we're going through it a little bit faster. I'm trying to get you back in the math mode, give you some thinking questions. But my expectation isn't that you necessarily know all of this right now. It's just we're trying to build some of your solving skills as we move on. All right. I hope you guys have a good day. Bye.